Project 2.4 Unpacked, the 555 timer. This project examines the 555 timer IC and its internal circuitry to demonstrate how it generates accurate timing and waveform signals. The 555 operates in monostable, bistable, and astable modes, allowing it to function as a timer, flip-flop, or oscillator. Its internal comparators, flip-flop, and discharge transistor produce reliable square wave outputs used to drive circuits such as a blinking LED, a piezoelectric buzzer, and a counting circuit. In astable mode, the 555 timer acts as a free-running oscillator, continuously switching its output between high and low. This creates a square wave signal that blinks an LED. The frequency of oscillation is determined by the timing components R1, R2, and C1. C1 charges through R1 and R2. While the capacitor voltage is below 1/3 VCC, the trigger comparator sets the SR latch, keeping the output high and the LED on. As C1 exceeds 1/3 voltage, the trigger comparator goes low, but the latch holds the output high. When C1 reaches 2/3 volt VCC, the threshold comparator resets the latch, turning the LED off and activating the discharge transistor to discharge C1 through R2. Once C1 falls below 1/3 VCC, the trigger sets the latch again, repeating the cycle and producing a continuous square wave. The unpacked 555 replicates this behavior using LM358 op-amps as comparators with a 3-resistor voltage divider, generating the 1/3 VCC and 2/3 VCC references. The comparator outputs drive an SR latch built from NOR gates, which controls the NPN transistor to discharge the timing capacitor, and also drives a 4069 inverter to provide a buffered LED output. The clock signal frequency and duty cycle can be calculated. At maximum potentiometer resistance, the frequency is 7.1 Hz, and the duty cycle is 50.1%. With no potentiometer resistance, the frequency rises to 480 Hz, and the duty cycle to 66.5%. These values are verified using the Arduino serial monitor. Application 1. A piezoelectric buzzer converts electrical pulses into sound. When driven by the astable 555 in the audible range, the buzzer vibrates at the output frequency. The PS1420 buzzer operates optimally at 2 kHz, which can be achieved by selecting R1, R2, and C1 to satisfy the 555 frequency formula. One combination is R1 equals 1 kilo ohms, R2 equals 3.1 kilo ohms, and C1 equals 0.1 microfarads. The resulting tone frequency is verified via the serial monitor. Application 2. Digital counters change output with each pulse, making clock signals ideal for counting. The square wave output from the inverter drives the 4510 BCD counter, which increments or decrements on each rising edge. Its 4-bit BCD output is decoded by the 4511 and displayed on a 7-segment display. Serial monitoring allows verification of pulse frequency and counting accuracy. In monostable mode, the 555 produces a single output pulse whenever triggered. Pressing the push button pulls the trigger below 1/3 VCC, causing the trigger comparator to set the SR latch. The output goes high, turning on the LED while the discharge transistor turns off, so C1 can charge through the resistor and potentiometer. The output remains high until C1 reaches 2/3 VCC, when the threshold comparator resets the latch. The LED turns off, the discharge transistor discharges C1, and the circuit returns to a stable state until triggered again. The pulse duration depends on the RC time constant on screen. For the chosen components, the minimum and maximum pulse durations are 1.1 seconds and 12.1 seconds, verified using the serial plotter. In bistable mode, the 555 functions as a flip-flop holding one of two stable states. Pressing the set button pulls the input low, setting the SR latch and driving the output high, which turns on the LED. The output remains high until the reset button is pressed, pulling the input low, resetting the latch, turning the output low, and activating the discharge LED to indicate the reset path. The output stays low until the reset button is pressed again, following the SR latch truth table. Thank you for watching.